Every time you type a web address into your browser and press enter, you're setting off a chain reaction that works exactly like placing an order at a highly organized restaurant. But before you can order your food, you have to know how to get to the restaurant. On the internet, your directions are the Uniform Resource Locator, or URL. This diagram shows how a URL breaks down into a specific hierarchy. Over on the right, you have the top-level domain, like .com, .gov, or .edu. You can think of this as the broad neighborhood. Right next to it is the second-level domain, like Google or MIT, which is the specific building you're looking for within that neighborhood. Moving further down the chart, we see subdomains branching off from their parent names. If the second-level domain is the building, the subdomain is a specific room or department inside it, like the admin or store sections of a website. URLs are designed specifically for human memory. We can easily remember a name like tryhackme.com, but computers don't read words. They navigate using exact numerical coordinates, which means we need a way to translate our human words into machine numbers. Those precise numerical coordinates are called an IP address, and to translate a human URL into a machine IP address, your browser uses DNS, the Domain Name System. It acts exactly like a giant phone book for the internet. This flowchart shows how that lookup happens. Starting at the top, your computer first checks its own local memory. If it doesn't know the IP address, it sends a request down to a recursive DNS server, usually run by your internet provider, to see if they have the number. If they don't have it either, the search moves deeper. The request drops down to the root DNS servers, the backbone of the internet. They act like traffic cops, pointing your request toward the specific top-level domain server that handles .coms or .govs. Finally, down at the bottom, the request reaches the authoritative server. This server holds the official record. It hands the correct IP address back up the chain to your computer, which saves a copy for next time. By handling this complex routing in the background, DNS bridges the gap between the words we remember and the precise numbers computers require. Now that your computer has the exact IP address, it arrives at the server's front door. To ask for the web page, it has to speak the server's language. This language is called HTTP, or Hypertext Transfer Protocol. Think of it as the strict etiquette you use to speak to a waiter. If you want to keep your order private, you use the secure version, HTTPS. This encrypts your request, which is exactly like whispering your order to the waiter so that no eavesdroppers can listen in. This image outlines what an HTTP request actually looks like.
The most common instruction is the GET method, highlighted here, which simply asks the server to retrieve a page. If you are submitting a password or filling out a form, you would use a POST request instead, which is like handing the waiter a filled-out piece of paper. By forcing every interaction into this strict set of rules, HTTP ensures both your computer and the server understand exactly what is being asked for, keeping billions of daily internet requests perfectly organized. There's one catch to this system.
HTTP is what we call stateless. This means the server has zero memory. The moment your web page is delivered, the server completely forgets who you are. To solve this, your browser attaches extra notes to your order called headers. These provide crucial context, telling the server things like what language you speak, or whether you're using a phone or a desktop screen. Look at the middle two panels of this communication log. To help the server remember you specifically, it sends back a special header called a cookie, in this case setting the name to Adam. A cookie acts like a VIP loyalty card, saved right on your computer. Down in the bottom panels, you can see what happens next. On every future request, your browser automatically hands that cookie back to the server. The server reads the card, recognizes you, and can keep you logged into your account. Without headers and cookies acting as a persistent memory, navigating the web would be a frustrating, amnesiac experience where you'd have to reintroduce yourself on every single page. Before the server actually hands over the website data you ordered, it shouts out a quick number called an HTTP status code. This announces the exact outcome of your request. If everything went perfectly, you get a 200 OK. If the website you're looking for moved to a new address, the server gives you a 300 level code to redirect your browser. But things don't always go smoothly. A 403 means you don't have permission to view the page. A 404 means the page simply doesn't exist.
And a 500-level code means the server itself crashed while trying to make your order. These status codes act as an instant diagnostic tool. They let your browser know exactly how to handle the server's response before it even tries to read the contents. If you get that 200 OK, the server finally prepares your meal. This happens in the backend. Think of the backend as the restaurant's kitchen. It's a combination of databases and server-side languages pulling raw ingredients together, completely out of sight. But the backend kitchen doesn't send you a fully plated, beautiful web page. It just sends raw code over to the front end, which is your web browser. Your browser has to act as the chef that plates the meal. It reads 3 types of code to do this. First is HTML. This is the structural skeleton of the web page, the meat and potatoes that define where paragraphs, headings, and images belong. Next is CSS, handling the styling. This is the garnish that dictates colors, fonts, and layouts. Finally, there's JavaScript, which controls the interactivity. It's the sizzling skeleton that brings animations and live updates to the page. By splitting work this way, servers only have to send lightweight text files across the internet. Your own device's processor then does all the heavy lifting of putting those pieces together and making them look good. Looking up coordinates, whispering the secure request, compiling data in the kitchen, and rendering code on your screen. All of this happens in milliseconds. The internet is a physical, highly literal system. Every time a page loads, billions of perfectly coordinated requests travel across cables and servers worldwide, serving up exactly what you ordered every single day.